Hi, this class we will talk about memory device. So, uh, we are going to learn three memory device. First will be the SRAM, and second will be the DRAM, and the third will be NAND flash. So, the SRAM and the DRAM are the RAM. So, the RAM are the RAMs or the random access memory and access memory. And the ROMs are read-only memory, so the NAND flash are included in the ROM. Mhm. Read-only memory. But the SRAM and the DRAMs are they have some volatile characteristic, and the NAND flash are the non-volatile character have a non-volatile characteristic. So the SRAM and the DRAM should be should always in power to the sustain the memory. But the NAND flash doesn't need power to save the memory always. So we'll talk about first of all, we'll talk about the SRAM. So SRAM are the static RAM. So the RAM will be the random access memory. So the SRAM will be static random access memory. So uh, in the circuit, the SRAM will be like this. So this will be the bit line, and this will be the word line. And mm, mm, I'm not I'm not good at drawing, so the picture will be not correct. So it's look like this. So we had learned that the CMOS will act like inverter. So the inverters are the devices that when we put zero on the input side, the output will be one. And when we have some input on one, and the output will be zero. So the inverter is kind of that thing. So this will be the transistor, and this will be the transistor. So when you have the word line on zero, the switch will be turned off, and when you have some one on the word line, the switch will be on. The so when we want to storage some memory, first we will have some word line on one. So the side of the switch will be turned on and put the memory on the bit line. So the memory will be 0, 1 or like this some kind of yes that thing. So when we put some 0 or 1 on the bit line and it will go through the switch because the switch are now turned on, and it goes on the two CMOS, and the two CMOS are will be the two inverter. So it'll looks like this. So when we have some even number of inverter, when we put on zero on the this kind of thing, the first inverter's output will be one, and the second the second inverter's input will be one, and the second inverter's output will be zero. So the memories are sustained. Uh, however, oppositely, when we have some input on one, the first inverter will have some zero output, and the second inverter will have some one output of one. So that example will have some same kind of memory storage. And when we have some, so this will be, we say latched up. So, and then when we have some word line on zero, the switch will be turned off and that the memory will not go over. So when we have some always on read on this side, when we always turn on, the memory will always be sustained. So, but when we have some VDD, zero VDD uh the on the CMOS side, the memory will goes go away. So will be the this is why that we called SRAM have some volatile characteristic. So and this we say 6T structure because it has a six transistor on the one cell. So it is big and very fast. So second, we'll talk about the DRAM. DRAM will be the dynamic random access memory. So DRAM. So first of all, we will draw the circuit of the DRAM, and then we will talk about why it is called dynamic random access memory. So this will be the bit line. So I'll just like this. So the this part will be the capacitor, and this will be the transistor. So it is 1T, 1C cell. So it is much smaller than the SRAM. So let's how it works. So when we have some word line on one, so the transistor will be turned on. So when we have some memory to storage, we'll have some we'll have we'll have input on the bit line side, the memory. So the memory will to this goes through the transistor and stays on this capacitor. So when then that's over, when then the storage process are over, we have some word line on zero, so the transistor will be turned off and the memory will be on the capacitor. But we had learned on electric circuit about the characteristic of the capacitor. So the capacitor are have some um the charge will goes down the very naturally as the times goes over. So that we talked about the capacitance. So the memories will be goes away the when the nat with the memory will away naturally as the times go. So that is the reason why we talk this kind of device dynamic RAM. So this kind of things of the losing of the memory is not related to the volatile characteristic. It is just because this is dynamic random access memory. So we have we have to do some process of it's named on refreshing. So we have to have some word line on one. So we have to visit the capacitor and we have to charge the capacitor to not lose their memory. So, but there are some kind of problem. So when we have some refreshing process, it consumption some it have some power consumption. So the devices will require more power. So the 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 power to sustain this memory will be goes high. So uh, we have to goes down low down the period of the refreshing. So how can we how can we low down the period of refreshing? So we have to large make big of capacitance. So we had learned capacitance or epsilon A over T. So the T will be the thickness, and the epsilon are will be the permeability, and the A will be the area of the capacitor. So we have to uh, we have to make epsilon bigger. So we can use high K material as we learned at the high K Mg on the other FETs. So, and we have to make the area bigger and we have to do the thickness more lows down the thickness. So yes, this is the how we make the DRAM. And finally, we will talk about the NAND flash. Hmm. NAND flash are the before we talk about the NAND flash, um, why we should use random access memory. So when we have some memory on the sequence, we have to when we have some sequential on the memory storage, when we put it is like, for example, when and there are like some kind of cylinder require case, and when we put this kind of one and zero, zero, one, and one, this have will have some sequential on storage. But when we have some storage, I want to check this memory, the most bottom side. So I have to pick up this side, this over, and finally I get this memory. So this is not efficient and it will make the device very slow. So we use random access memory to have our memory very efficiently. So this was the reason why we use random access memory. And finally, we will talk about the NAND flash. NAND flash or the ROM. So it is just read-only memory, and it have some non-volatile characteristic. So, mm, NAND flash are like one T cell. It have on one T on the one cell. So the structure will be, I will draw the NAND flash using energy band diagram. So I had talked this or one T. So what one T means it has one transistor, but we had learned how to draw the one transistor's energy band diagram. So this will be the metal side, and this will be the oxide, but we talk this oxide blocking oxide, and we use here some kind of insulator, another. We use here some kind of oxide here. And we talk this side tunneling oxide, and we use here semiconductor. So this will be the this will be the NAND flash energy band diagram. So I will show the I will show how it work. So mm these two are the oxide. So in generally they cannot the carrier or cannot go through the oxide, but we use the tunneling. So the names are the tunneling oxide. So let's go very close. Let's look the tunneling oxide very closely. So this is the closer but version of the tunneling oxide, but when we have some plus bias on the metal side, the oxide will have some bending on it. So it will bend like this. I will draw this part, the bending oxide, red. So this will be the bended tunneling oxide when we have some plus bias on the gate side. So, but when there are the carrier on it, there they feels the when before the gate bias, they feel that the the walls of the oxide are very thick, but when we have some plus bias on the gate side, the effective thickness thickness will be very it will be very lower to the carrier. So the carrier can go through the oxide by tunneling. So the carriers will goes here. But the blocking oxide are very uh, thick, but so they can go over go through the blocking oxide. So the it is the reason why we talk the blocking oxide and the tunneling oxide. So we make blocking oxide very thick and the tunneling oxide very thin. So when when there are none of carrier on the between the blocking oxide and the tunneling oxide, let's have some example. The threshold voltage will be the 5 volt, but when there are some carrier on the between of the oxide, let's have some that makes minus 2 volt. So we have to we have some we need to have some 7 volt on the gate side to effectively have some 5 volt on the channel side. So the threshold voltage had been increased. So when we have some ID, IDVD, IDVG curve on the NAND flash, so first of all, it was first 5 volt, but when there are carrier on between the oxide, the threshold voltage will be increased. And on the IDVG curve, it have been shifted on the right side. So when we have some 6 volt on the gate side, when there are current flowing on the transistor, we will have this part will be 0. And but when there are none of current flowing, we will have same that we will talk that the memory are now 1. So these are the these are now splitted the threshold voltage 2, but we can make this 4 this will be now 1 bit, but we can make this 2 bit. So when we have some more threshold voltage standard, and this will be 9 volt, and this will be 11 volt. So when we have 6 volt on the gate side, when there are current flowing, we will talk this 0, 0. But when there are not current flowing now, and then we have some 8 volt on the gate side, and then when there are current flowing, we'll talk that or the memory will be 0, 1. And then, but when there are not current flowing, we will have some 10 volt on the gate side. And then when there are current flowing, we will talk that there are now 1, 0. And then we can say when there are not current flowing on the transistor, so we can say this 1, 1. So we can use this example like to split it threshold voltage and the four splitted threshold voltage, and then when we have to make 3-bit memory size, we have to split the threshold voltage 8 and then 16, and it goes higher. So this was the how it's work on the NAND flash. So I talked about the SRAM and the DRAM and the NAND flash. So thank you for watching my video. So yes, we will, yes.